So this one is first the introduction that okay, just a brief introduction to different names. We're going to use some names which we would frequently be using, referring to. So we need to understand the meaning of those terms. And the first one is what's an electrophile? That's the first term that we will be using. So electrophile is going to be referred to whenever you use the term electrophile, that's going to be used for a species. It could be an atom, a molecule, or an ion, or whatever. It's a species that is attracted to a negative charge. So it's attracted to negative charge. Now that negative charge could come in many forms. It could be a partial negative charge. It could be a full negative charge like -1. It could be a double bond. Okay, so that negative charge could be a slight negative charge, a negatively charged ion. It could be a double bond because double bonds have electrons. So the double bond is negatively charged. So anything that's attracted to something negative, that's what an electrophile is.
So is this a new topic?
Yes, we're done with isomers. It's still organic. Okay, we're starting with we're going to start with alkanes. Okay, Hania, is that clear?
Yes, sir. Thank you.
So anything that is attracted to negative charge, and not only is it attracted to negative charge, but can accept a pair of electrons or gain a pair of electrons. A pair of electrons. Then you have another thing that's going to be referred to as a nucleophile. What's a nucleophile? It's going to be the exact opposite. It's something that is attracted to positive charge. So it's a species that is attracted to positive charge. And again, this positive charge could be anything. It could be a slight positive thing. It could be a fully positive ion. When I say slight positive, that means like you have an HCl molecule. Now this HCl molecule has a slight negative side and a slight positive side. So it's not a it's not a -1 or +1 ion. It's just a slight partial positive, partial negative charges. Okay, that's what I mean by that. So anything that's positive, species that is attracted to positive charge, or something that is electron deficient. So it could be attracted to something that is electron deficient. An example of that is like you have an AlCl3 molecule. Now in AlCl3, the electrons of AlCl3 are not complete. Aluminium still needs electrons. So it's electron deficient in a way that its outer shell is not complete. So species that is attracted to positive charge. And the other thing about this is that it's capable of donating a pair of electrons. And we'll discuss in detail a lot more detail just in a while. And can donate a pair of electrons. Then there's another term that's known as free radical. So free radical is something that has unpaired electrons. So it's a very reactive species. And it has unpaired orbitals or electrons. An example is a Cl atom. If you look at a Cl atom, it's got 17 electrons. The outer shell of Cl is 3s2, 3px, 3py is also full, and the 3pz has just got 1 electron in it. So that's unpaired. It needs an electron. Its outer shells are not complete, so it's going to be very reactive. It's going to try and bond with our other atom. It's going to try and gain those electrons. So these are some words that we will frequently use: electrophile, nucleophile, and free radical. You must know what the meaning of those words are. Something that's attracted to negative, that's electrophile. Something that's attracted to positive things, that's a nucleophile. And a free radical is something that has unpaired electrons. Its outer shells are not complete. And it would try to bond with anything. It's going to be very reactive. Is this clear, everyone? Yes or no? Is this clear?
Yes.
Acha, phir isi tarah you've got another thing that's called, there are two types of bond breaking, which you should know of. Number one is called homolytic fission. So that's our number one. And this one is known as homolytic fission. What happens in homolytic fission is that that the bond breaks equally. And when it breaks equally, usually it's free radicals that are formed. One example for that is you've got an HCl, a Cl2 molecule. A Cl2 molecule has one bond between the Cl atoms. So one of the electron goes back to one Cl, the other electron goes back to the other Cl. So that results in the formation of radicals. And two of them. Because this Cl atom now has, it's short of 1 electrons. Now I forgot to mention that radicals are usually referred to by a dot. Like when you see a Cl with a dot on top or on the side or anywhere, that's a radical. That means its electrons are unpaired. For example, you've got CH3. So that's also a radical. A nucleophile, on the other hand, is usually referred to as 2 dots. For example, OH -1, something that's attracted to positive things and can donate a pair of electrons. NH3. So it's usually referred to or written with 2 dots. Those 2 dots represent that it's capable of donating a pair of electrons. So 1 dot is a free radical. Electrophiles, you don't write any dots with that because it's something that is electron deficient, can accept a pair of electrons. So it doesn't have electrons to begin with. So anyways, this is homolytic fission, that the Cl atom and the bond in the Cl molecule, it breaks equally. Each atom gaining its 1 electron back. Okay, is this clear? Hania, is this clear, Anna? The rest?
So could you
Yes.
explain that one more time, please?
He says homolytic fission is that when atoms make a bond and the bond breaks equally, like 1 electron goes to one of the atoms, the other atom gets the other electron. So that's what homolytic fission is. Is that clear?
Yeah, but how would it why would it lose an electron? Isn't chlorine supposed to gain one?
What do you mean lose an electron? Like,
You said that, and when they're bond breaking,
yeah,
they lose an electron.
they don't lose an electron when the bond breaks. One atom gains it. I mean, the bond breaks, right? The electrons have to go somewhere. So one of the electrons goes
Yeah,
back.
yeah. I just
Take care.
thank
So,
you.
so they both. Yes, Abdullah.
Sir, what if it's the case with an oxygen which forms a double bond, like
s-
with the carbon?
The same thing. If the bond breaks equally, like the electrons are split equally between the two atoms, then it's going to be called homolytic fission.
So they will share, like they will, if for example, when carbon forms a double bond with oxygen, so there are 4 electrons being shared.
Yeah.
So carbon will keep 2 and okay. Sorry.
Okay. So the homolytic fission is going to be used. The word would be used when the bond breaks equally. That's it. The other one, like if the other one would make it clearer because the second one is heterolytic fission. So what happens in heterolytic fission is that the bond doesn't break equally. In heterolytic fission, one of the atom gains both electrons. So, so the definition would be bond breaks unequally. Why does it happen? We're going to figure that out later on. Bond breaks unequally, and usually ions are formed because one of the atom ends up gaining both electrons. So you've got an HCl molecule. It's got electrons. Both electrons are gained by one of the atoms, which, for example, in this case is Cl. So now H would be left without electrons, and Cl would be the one that would be gaining both electrons. So it would result in the formation of Cl-1 ion, which would also be this would be a nucleophile, this one over here. Why? Because it's going to be attracted to positive things. Or vice versa, this would be an electrophile because this would be attracted to negative things. But anyways, the thing is that the bond breaks unequally. Both electrons go to one of the atoms, and that results in the formation of ions, positive and negative. So is that clear? Alicia, is this clear? Abdullah, Aiza, is this clear?
Yes, sir.
So that's one thing. And then you've got these curly arrows. You've got these curly arrows. What do they represent? So curly arrows are, they describe the movement of electrons. Okay, so if you have a full arrow like this, that shows the movement of where two electrons are going. And if you have a half arrow, or just half a arrowhead, that shows the movement of just one electron. Like over here, if you see carefully, if you have a look, you have lone pairs, both electrons are moving towards the Cl atom. So that's a full arrowhead. One curly arrow represents the movement of a pair of electrons. On the other hand, over here you had half arrowheads, because one electron, the arrow shows the movement of one electron, and this arrow shows the movement of the other electron. Is this clear?
Yes, sir.
Okay, so just remember what these curly arrows they represent. And so now what we can do is we can start talking about, we had done naming. And we had talked about alkanes earlier as well, at least the naming part. Now, the first thing we're going to talk about when we talk about alkanes is their physical properties. Okay, and remember, we're going to be referring these terms over and over again when we study reactions. Okay, so just a brief recap. Electrophile is something that's attracted to negative things. Okay, just remember electrons, so it's attracted to electrons. Nucleophile is something that's attracted to the nucleus, which is positive, so something that's attracted to positive things. Free radical, something its outer shell is not complete, its electrons are not paired, so it would be very reactive. It would try to bond with things. You've got homolytic fission, heterolytic fission, and then you have these curly arrows. So the first thing is we're going to talk about alkanes and their physical properties. So now about alkanes, they are saturated hydrocarbons. Which kind of means that they've got single bonds, carbon and hydrogen atoms. And you got single bonds. So the physical property is that they're going to have, compared to the other ones, they're going to have low melting and boiling points. That's the first physical properties. And the reason why they have low melting and boiling points is because like if I have an ethane molecule, and I've got another ethane molecule. Can you even quickly tell me what is the intermolecular force that's going to be present that would attract one ethane molecule to another ethane molecule? So what's the force of attraction between them? Anyone, any idea? What's the intermolecular force that exists between these molecules? Anyone, any idea?
So could you repeat what you said?
And what's the name of the attractive force between the two molecules that's going to exist between them? There are three types. Van der Waals forces. There's three types of intermolecular forces, and what's going to exist between them is going to be Van der Waals forces, because remember that this molecule is completely non-polar. Carbon, I mean, this would be Van der Waals forces. I mean, that's the name of the intermolecular force. And the thing with this is that, just one second. Just hold on one second. Anyway, so it's going to be Van der Waals forces, and the reason it's going to be Van der Waals forces is that remember that carbon and hydrogen have very little difference in electronegativity. So carbon and H atoms, they almost have the same electronegativity. Which means the tendency for them to gain electrons is kind of the same. So the electrons in any of those bonds, they would be evenly distributed. It's not going to be I mean, this bond, if you focus on this bond, the carbon and H bond over here, it's almost going to be non-polar. Okay, they won't have any polarity. There's no partial positive, partial negative. So the only thing that's going to be going on would be the random fluctuation of electrons. Like molecules would be bumping around. So maybe at 1 second, the electrons might randomly get pushed to one side, and this side would become partial negative, and this side would become partial. It would become partial positive. In the second instance, the collision might happen and the electrons kind of get pushed to this side. This side would become partial negative. This side would become partial positive. So there's going to be random fluctuating dipoles, which would be known as temporary dipoles and induced dipoles, or in other words, they would be called instantaneous dipoles. So they would be referred to as instantaneous dipoles, induced dipoles. So there's going to be random fluctuation, and the molecule will attract other molecules, but they would be because of this van der Waals forces. Is that point clear? Okay, everyone, is this clear?
Yes, sir.
Okay, and I'll just quickly just hold on 1 minute. Take it. So just explain this again. You're going to have an instantaneous dipole. The electrons might, during collisions, might get knocked to one side. This side would become negatively charged. On the other molecule, there's going to be induced dipoles. Because of the negative charge over here, the electrons of the other molecule would get pushed away. And this side would become negatively charged, slightly negatively charged. And this side would become slightly positively charged. And the negative sides and the positive sides would attract. I mean, the negative side of one molecule will attract the positive side of the other molecule. In the second instant, the dipole might vanish. And there's going to be random collisions, and something else would happen, that another dipole would be created, and this time the electrons get knocked to this side. So this side would become negatively charged, this side would become positively charged. The electrons of the neighboring molecule are going to get attracted to the positive side over here. So its electrons will get attracted to this side. This side would become negatively charged, this side would become positively charged, and there's going to be attraction between them again. So that's van der Waals forces, randomly fluctuating dipoles that would produce attractive forces between the molecules. Is this clear? Anna, is this clear? Hania, is this clear? Alicia, is this clear?
Yes, sir.
So So the thing is, you'll have these fluctuating dipoles and van der Waals forces, and which are weak, which are kind of weak. Van der Waals forces are weak. These intermolecular forces are relatively weak compared to the other ones. So does anyone remember the factors which affect van der Waals forces, like the strength? It's relatively weak compared to the other ones. Now, the strength of van der Waals forces depends on two things. One is increases with size. And also increases with size, and the other thing is surface area as well. To get two of the factors on which van der Waals forces. So the bigger the molecule, van der Waals forces are going to be greater. So what happens is they do have low melting and boiling points, but the melting and boiling points increase with size. So remember this, that melting and boiling points are going to increase with size, as you're going to have more van der Waals forces. Bigger molecules will have more fluctuating dipoles because they've got more electrons. So they increase with size due to greater van der Waals forces. So that's one thing. The second point is that they're not going to be very soluble. So that's point number 2. And that's about their solubility. And the reason they're not soluble is that they're non-polar. So not soluble in polar liquids like H2O. Because remember, H2O is highly polar. It's got hydrogen bonding going on, so it's a very polar molecule. So the water molecules, they attract other water molecules very strongly. Water molecules are extremely polar, and your alkanes, they're very non-polar. So they're not going to attract each other. Okay, so highly polar, it's going to probably attract other water molecules. So they will form separate layers. I mean, the water molecules are going to attract each other very strongly because of the large polarity that exists. And the ethane molecules are not going to be attracted to them. So not soluble at all. Those are the two, three main points about solubility and the melting point. They're obviously not acidic or basic. They're completely neutral compounds. That could be a third property. So they're not going to lose H+1 or gain H+1 ions. The other property number 4 could be that no electric conduction, because obviously they don't have any charges. So no electric conduction would be happening for alkanes. Now moving to the reactions, reactions of alkanes. What's going to happen when alkanes react? Alkanes have very few reactions. The first thing is that alkanes are kind of unreactive. So reactions of alkanes so not very reactive. So they are unreactive. Why? What's the reason why they're unreactive? Because if you have a CH4 molecule, what happens is that it's not going to attract other molecules. It's a non-polar molecule. So it's a non-polar molecule that doesn't attract other molecules. So very unreactive because it's got no slight positive, slight negative charges, and there would be very little attraction for other molecules. But they do have one reaction, and that is the free radical substitution reaction. That's a free radical substitution. And this reaction happens with halogens. Mostly it happens with Cl2 or Br2. And you need UV light for that, or sunlight. So this is basically your sunlight. So you need sunlight for this reaction. And you've studied this. This was just one reaction that you studied in O-levels as well. Free radical substitution. The overall reaction is kind of simple. In the overall reaction, what happens is that you take an alkane. Let's say I take an ethane molecule. It reacts with a Cl2 molecule in the presence of UV light. And one of the H atoms gets substituted by one of the H atoms gets substituted by Cl. And an HCl molecule is produced. Now it could be one, or it could be a number of H atoms could be substituted, not just one, but many H atoms can theoretically be substituted. So what you can get is a multiple or many different compounds. You've got, I mean, this could be one option that like 3 Cls can get substituted. So the substitution is kind of random. It could be many Cl atoms getting substituted, but always an HCl molecule is produced right next to it. Okay, is this clear? Abdullah, is this clear? Mayam, is this clear? Anna? Nabila, is this clear?
Yes.
So it looks like a simple, yes, Abdullah.
Sir, why are 3 chlorine atoms substituted when only 2 were involved in the reaction?
You can increase the number of Cl2 molecules accordingly. I mean, all 6, I mean, just if I replace this molecule over here with this one, you can just balance it. You can increase the number of Cl2 molecules. Okay? Abdullah, is this clear?
Okay, yeah.
So the point is that you can have a number of H atoms getting substituted, and that's free radical substitution. But this is the overall reaction. The mechanism of this reaction is kind of way more complicated. It's a lot of things happening in the mechanism. So we're gonna briefly discuss, not briefly, but in a lot more detail. We're going to discuss the mechanism for free radical substitution. Remember, reactions are not that simple. Reactions involve a lot of steps. So the above reaction that I wrote down, that involves a lot of steps in it. So mechanism of free radical substitution. The free radical substitution involves 3 steps. I mean, the reaction that you just saw over here, that has 3 steps. It's got an initiation reaction. Okay, that's the first step, step number 1. Okay, so I'm gonna write down the steps. So the first one is initiation. That's the step in which free radicals are formed. Then you have a second step, which is known as propagation. In this step, total free radicals, they remain the same. And then you have the third one, which is termination. In the termination step, the free radicals get used up. As you got these 3 steps happening. So we can talk about the first step. Okay, let's just talk about this in the next class, TK, because we're going to run out of time. Just remember that it's a simple reaction with a very complicated mechanism. It's got the reaction is simple. It's got a Cl2 molecule that's going to come in and it's going to just displace one of the Cl atoms or 2 of the Cl atoms or all of them. And as a byproduct, HCl would be formed. But the mechanism and the steps involved in the reaction are many. So this reaction and its mechanism, we're going to study that in detail. We did the physical properties of alkanes, TK, and we learned the different meanings of the different terms that we are going to use from now on, TK. So let's continue with the mechanism in the next class. This alkanes only have just one mechanism, so it's not it doesn't have a lot of things. Just a second. TK, just 1 second. Let me share it right now. So yeah, let's talk in the next class. I'm sharing the board link on the group.
Allah Hafiz.
Hafiz.
Thank you.